Now, in the second video, I wanted to split these up so that we had the inverse trig functions separate. Now remember, the inverse trig functions are used when we want to find a missing angle, where we don't know theta. So we use inverse sine, inverse cosine, and inverse tangent. And we use those on the calculator. They're pretty straightforward. So if you look at this example problem, we don't know theta. But what we do know is we know the hypotenuse and we know the opposite side. So the sine ratio uses O and H. So what we can do is we can set up theta equals sine inverse of O over H, 12 over 15.7. And we go to the calculator and we find our sine inverse. And it's in different places based on different calculators. And you want to make sure that you're in degrees because theta will be in degrees. And I'm getting something about 49.8. Now, nearest degree would be 50 degrees. Pretty simple. Let's take a look at this one. We don't know theta, but we do know the opposite side and the adjacent side. So O and A form the tangent ratio. So theta equals tangent inverse of O, which is 11, over A, which is 7. Tap it into my calculator. 11 divided by 7. And I'm getting 57.5. And this is multiple choice. So it looks like it would be D. So that's how we do the inverse and solve for a missing angle. Not too hard, not a new concept, but just something we want to review. Now here, what you have is a nice little sketch, two actually nice little sketches of angles of depression and elevation. I particularly like this one over here on the right because it shows you the 55 and the 55. Why is that important? Because the angle of depression and the angle of elevation are really the same amount. And the reason for that is because when you look at that diagram, you have parallel lines cut by a transversal, and those angles, the 55 and the 55, or here, the 20 and the 20, are what we call alternate interior angles, way back to your geometry days. Now again, that's not something that you have to know per se, but that's a very nice relationship because I like to always treat everything as an angle of elevation problem. I like to simplify it a little bit. So if you look at this example, chairlift at a ski resort, angle of 20.75 while traveling up a mountain, and attains a vertical height of 1,200 feet when it reaches the top. How far does the chairlift travel up the side of the mountain? So that would be D. That's what we're looking for. Now this right here, the 20.75, that's our angle of elevation. But it could just as easily be here and be an angle of depression. So really this is not that difficult of a problem. We're basically just using our SOHCAHTOA to solve for D. So here, this is your theta, this is your H, this is your opposite side, opposite from theta, and the ratio that uses O and H is sine, We know theta, so we don't have to use the inverse here. So O is 1200, H is D. So when we cross multiply, we get D times the sine of 20.75 degrees. Now how do we solve for D here? This is no different than having a coefficient in front of D. We divide by that number. So we're going to divide this side by sine 20.75, this side by sine of 20.75. And if I tap that out into my calculator, 1200 divided by sine 20.75, I get approximately 3,387 feet. That's my hypotenuse. So that works. That's the longest side. So that's really where we are as far as reviewing trigonometry. We usually take a day and just try to get this review done before we move on to our other topics in trigonometry.